Hello and welcome. This is the first chapter from our Intertech class, Complete Spring Core. My name is Jim White, and I'll be introducing you to the Spring Framework. Exactly what is Spring? Maybe more precisely is, what is the Spring Framework? Well, it's an open source application framework. That says a lot, and maybe not too much, depending on how you view it and depending on what your background is. Open source, of course, means it's freely available to the general public for use, and for that matter, for modification. You can change the Spring Framework to meet your needs. There are many frameworks out there in the Java community. Most notably, there are frameworks such as Struts that allows us to develop things like web MVC applications. You might also be familiar with things like Hibernate to allow us to persist object data into a relational database. The Spring Framework, however, is what we call a whole application framework. In other words, it isn't meant to address a particular layer, it's meant to address all layers of our application environment. So it's a framework that provides code, libraries, as well as guidance and structure about how to put entire applications together. It originated from Rod Johnson. He's an Australian who wrote a book back in 2002 that essentially said there's probably a better way to build applications than using some of the Java 2 enterprise framework that we have available today. Not that the J2E framework isn't good, but it is a little bit cantankerous to use in terms of its complexity and really gets to the low-level details without giving us maybe something that abstracts away some of the complexity. Spring 1 was released in 2004. Today we're up to version 3. This slide set is a little bit dated. It's now in final release, went into final release as of December of 2009. So given its age and comparison to other frameworks, it's a relative newcomer to the Java landscape. You'll find out lots more about the Spring Framework at springframework.org. Again, why was it created and what's its purpose? To reduce the complexity observed in a lot of Java enterprise application environment. Again, most notably in things like enterprise Java Beam. The name Spring Framework, and in particular Spring Beans, which really make up a large portion of the Spring Framework, has a name that, if you will, kind of is parallel to the name Enterprise Java Beam, both containing that bean name for a reason. Mr. Johnson felt that there really needed to be a better and improved way of building applications, a better bean environment, if you will. And so Spring tries to do that. In his own words, Mr. Johnson said that Java enterprise applications are overly complex and take a lot of time to develop. So how can we improve that? How can we, out of the box, provide a more attractive environment? J2E does a great job of standardizing our low-level APIs and providing us a means to write once and run anywhere. But in many cases, it's much too complex for the average developer to have to get into all the details of all those APIs in order to build even the simplest of applications. So Spring is meant to be a lightweight framework. By that, what do we mean? Well, it's meant to try to reduce the complexity you ordinarily find in a lot of the Java enterprise APIs. Spring leverages plain old Java objects, POJOs, or maybe a little bit more precisely, Java Beans, to try to build enterprise type of applications. However, it should be noted that just because the framework is there to help us build enterprise applications, we don't have to be working on an enterprise application. It could be a non-enterprise environment that we're building. Say, for example, a Swing application that's going to run on clients that maybe communicates with back-end enterprise systems. Spring can be used for that as well. So Spring is an environment that helps us build all types, shapes, and sizes of Java applications, and tries to do so in a way that's not maybe as complex as we might find in some of the underlying APIs, the Java Enterprise APIs that it uses underneath the covers. Now that adjective lightweight that we talked about in the previous slide is used in several connotations with regard to Spring. Yep, it's lightweight and it helps reduce complexity, but literally, physically, it's also lightweight in size and code. In other words, if we take a look at the Spring Framework, at least in its initial distribution, the jar size was about 2.5 meg. If you look at lots of frameworks out there, especially given the fact that Spring Framework does so much for us, looking at it in comparison to a lot of other frameworks, that's pretty tiny. Now, it's gotten a little bit bigger since its initial releases, and today too it's not released in a single jar file. We'll talk more about that later on in class. But still, with regard to its behavior, it still tries to be what we call non-intrusive in a lightweight fashion as well. In other words, rarely requiring any of our application code to extend or implement something in the Spring framework. In other words, rarely do we have to extend or implement some Spring class or interface in order to make our applications work. Why is this important? Well, it allows for us to take out the Spring framework without tearing out all of our application. In other words, it works to be non-intrusive and incorporate best-of-breed frameworks and best-of-breed ideas without causing large chunks of our application code to have to change. Now, it should be noted that there are alternatives to the Spring framework. In fact, Spring framework brings together lots of ideas that we'll be talking about throughout class, things like dependency injection and aspect-oriented programming. But these concepts existed long before Spring ever came into fruition. Spring just happened to make them very, very popular. So when we talk about these alternatives in many cases are older than Spring. For example, if you take a look out there on the World Wide Web and search for things like dependency injection frameworks, you might find something called Pico Container or HiveMind, which is now no longer really being maintained and has kind of been co-opted by a lot of the other ideas and frameworks that are available to us today in the Java community. Google, in fact, has another lightweight dependency injection framework that has certainly gained some acclaim called Juice. So, Spring, yes, it is a framework for entire application development, and it is the largest and most feature-rich, at least in this author's opinion. However, it is not the only framework, but it does still continue to receive overwhelming support given its size and given its capabilities. It has become very, very popular very, very quickly. Now, Spring has some philosophies about how applications should be built, and these philosophies are intertwined around the API and the constructs available to us in the Spring environment. Many of these originated with, again, Mr. Johnson's book, Expert 101, Java 2 Enterprise. So, what are some of these philosophies? Well, first of all, Rod Johnson and company felt that enterprise applications should be, again, easy to create. In fact, in some cases, you might actually find the word fun associated with application development again. When's the last time you had fun building an enterprise application? The framework should again be lightweight. We talked about how that is both in its non-intrusive behavior as well as physically in its size and shape and makeup as far as distribution of the jar files. We talked about how the framework should be non-intrusive, providing us a mechanism to build applications but not having us to lock in to the Spring API through either extending classes or interfaces implemented by Spring. The idea is we should be following best-of-breed solutions, and Spring espouses the fact that you should use best-of-breed solutions, which in some cases may not be the Spring framework, and they believe the API should dovetail into whatever that best-of-breed solution might be. What other philosophies does Spring espouse to? Well, they believe that good and simple design should not be compromised by the underlying implementation technology. Many of you probably started off your software careers, especially if you were learning object-oriented development, with something known as Object-Oriented Analysis and Design, OOA&D. Probably learned things like UML and how to build applications using essentially philosophies from some of the engineering community about how to first design and then build our applications. But in reality, it becomes pretty difficult, especially in enterprise technology, for using good object-oriented analysis and design capabilities. Why? Because they're tough to really keep up with what the actual application is as the application is being put together. In other words, the models that we see in object-oriented analysis and design often don't reflect the ultimate end code. Because the end code, the enterprise technology, usually has to be too intertwined with something like EJBs or other frameworks to really facilitate good parallel connection to the original design models. Spring says that's nuts. We should really be able to use those good technologies, those good techniques we learn in good analysis and design independent of any kind of implementation, and be able to use those throughout the life cycle of our applications. What are some of the other philosophies that Spring espouses to? Good applications should be easy to test. Now, most of us are probably familiar with unit test frameworks like JUnit. However, how many of them can you use today, especially in those enterprise environments? It's tough to unit test applications that are running in things like Tomcat or WebSphere or WebLogic. We usually have to have a lot of apparatus up and running before we can even get one line of code executed. That makes it somewhat prohibitive to environments like JUnit. So testing enterprise applications, especially when they're comprised of very tightly coupled components like EJBs, is often difficult or sometimes impossible. Yes, there are some test frameworks that work in these environments, but they're not altogether easily transported from one environment to the other. So Spring says again, this is nuts, no way to run a railroad. We need to provide an enterprise environment, a framework development environment that supports good unit testing. Coding by interfaces is also something that Spring espouses to. Now this is a rule as good developers we should do regardless of our framework, but typically we don't always think about building an interface first and then building a class to implement that interface. Well, Spring kind of espouses and actually, I don't want to say enforces, but highly encourages to think interface before we think about code implementation, or if you will, class implementation. Interfaces provide for a much more loosely coupled and pluggable type of solution. And Spring really does, through its API, help to encourage that type of interface first, class implementation second type of philosophy. Spring says we don't want to compete also with good existing solutions that might be there today or there tomorrow. For example, Spring provides an MVC web development environment. However, they say if you like struts, if you like Tapestry, if you like JSF, we'll integrate to those environments just as well. And there might be technologies in the future that you like better in certain areas of the application environment that we should be able to integrate with. Spring believes use what you are familiar and like about other environments, and we'll try to provide the fill-in, if you will, the gaps around the rest of the application development. And lastly, one of the philosophies that Spring espouses to is that checked exceptions usually serve little or no purpose. This is something even James Gosling has questioned in recent years about whether or not checked exceptions maybe have been a little bit too highly used, or maybe another way to say that is too prominent in our Java language. So a lot of times we'll find that in checked exception try-catch boxes, we'll find little to no reaction to those exceptions that occur, because in many cases the application can't do much about it. Think about things like SQL exception, for example. It's usually very difficult to recover from some sort of SQL exception error, such as the database being down, or maybe the SQL string being provided is incorrect. So what Spring says, when a checked exception really can't be recovered from and serves very little purpose, why detect it and why even capture it? So a lot of what Spring espouses to works on runtime exceptions, and we'll talk more about that in class as well. So the bottom line is Spring provides a framework that many say promotes applications from a development perspective that are easier and less complex to develop, easier to test and therefore of better quality, and much more flexible and therefore easier to maintain. We hope you see those principles and the results of those principles come out in class over the next few days. Now, applications built on top of the Spring framework are largely comprised of simple Java objects. Again, POJOs, plain old Java objects. These objects are generally configured with XML, although more recently, especially with more recent editions of the Spring framework, they may be configured by things like annotations. Now, in addition to the API and the framework that Spring provides, the framework is actually more than just that API, more than just the general constructs of building application. It also provides what's known as a container. If you will, the Spring container is what actually manages the lifecycle and the configuration of our application objects, which are those Spring POJOs, Spring Java objects, which we call Spring Beans. So in fact, your Spring Beans, or POJOs, live inside of the Spring container, and of course that Spring container is running inside of a JVM or other type of container, such as an application server, WebSphere, WebLogic, or web container, like Tomcat. So indeed, what we have now are components running inside of the Spring container, and then the Spring container running inside of potentially other containers, or at the very least running inside of the Java JVM. So the Spring environment, the Spring framework, provides us a set of API, set of principles and constructs around how to build enterprise or maybe non-enterprise applications, as well as an environment to actually run those applications, and that being the Spring container. As I mentioned, the term bean here that we use, Spring Bean, was not chosen by accident. The term Spring Bean, again, is a takeoff on the idea of enterprise Java Bean. Mr. Johnston and Company felt they wanted a less complex framework and therefore a less complex type of EJB component to build our enterprise applications with. So at its core, Spring Framework is basically based on two key technologies, and we're going to learn these two throughout class, one being dependency injection and the other being aspect-oriented programming. Both help to serve in promoting loose coupling and building applications that are, again, easier to build, easier to test, and of better quality, and more flexible. The first concept, dependency injection, otherwise known as DI, is how objects or beans, again using the Spring vernacular, are brought together by the container to accomplish some sort of task. When we think about application code, we're often talking about many components, many objects working together to get some work done. Well, the same thing happens in a Spring application. But dependency injection, also known as inversion and control, or IOC, is a means by which we give the Spring container to help us assemble those objects to get work done. An example is in order here to help simplify this idea. Let's say, for example, we were building some sort of application where we had a customer service object. And like most service objects, it must get data in and out of a database. And so we also devise some sort of, let's call it customer data access object, or customer DAO, to get data in and out of the database. Now in many application worlds, what we need to do is somehow get our customer service, its customer DAO, through some sort of lookup, something like JNDI, or maybe even just do it manually. In other words, we give customer service a DAO property, and then say that DAO property equals new customer DAO. Well, that's how we do things in the world today. But in dependency injected worlds, we're going to find that we never ever create new objects in our code. We allow the container to give things like the customer service object its customer DAO. Now, how is that done? Well, not a lot of tricks here. It has to be done through configuration, again, either done via XML or annotation. And we'll talk more about that principle in much more detail later on in class. Now, the other key technology that is part of Spring is something known as aspect-oriented programming, otherwise known as AOP. And if you will, AOP is really a framework within a framework. In other words, AOP is a framework inside the Spring framework. What does AOP give us? Well, it allows us to develop what are called cross-cutting system concerns or services in code that is isolated away from business logic. I want you to think about how, for example, you might have handled logging in your most recent application. If your logging has been accomplished how I've had to do logging in lots of applications, there's probably dozens and dozens and dozens of lines of code spread throughout just about every class that essentially handle the logging. When an exception occurs, you print something to the log. When a record is stored, you print something to log. So while there might be a set of log classes, you have to call those log classes from literally hundreds of places throughout your application. Using aspect-oriented programming, what we'll do is develop these services, these cross-cutting concern services like logging, auditing, security. In other words, kind of the ash and trash that any application must have, but these are concerns that are not related to business itself. In other words, it's not about taking orders or processing any kind of order or taking care of billing. It's all about just taking care of the system concerns of our application. We're going to put that code in separate classes. And then, through declarative links, typically again through XML or in some cases annotations, we're going to apply the calling of those services, things like logging, security, transactions, through this framework, have them be taken care of automatically almost, if you will, and applied through the business code without that code actually residing in our business code. In other words, without having logging actually written into our order entry services or our business order services or billing services. So we're taking care of these cross-cutting concerns without actually having the right code in the actual business logic. So it isolates that which is system-y stuff from that which is business stuff. We'll learn more about AOP as well as dependency injection later on in class. Now, while Spring is based on simple plain old Java beans, again, what we call in the vernacular of Spring, Spring beans, Spring today is a large and all-encompassing framework. In other words, it's meant to tackle almost every part of our enterprise, in some cases again non-enterprise applications. So in order to help facilitate building applications across so many kinds of application areas, Spring is actually organized into several different modules. And these modules serve a couple purposes. In some cases they help us to bring that particular module into our environment through a jar file, but also help us to find and utilize particular pieces of the Spring framework that we might have interest in. So there are modules to help us with things like persistence and things like monitoring and configuration, dealing with messages. Just about any kind of application need we might have, there's probably a module in Spring today available for us to use. Now this is an often cited picture you'll see in a lot of Spring documentation, kind of the key modules that you'll need for many applications. We've got the core module, then we've got things like the web module, data access objects, aspect-oriented programming module. Some of these we're going to talk about here, and then some of them we'll follow up with chapters in the rest of our class. So each module contains API, in other words code we can use in our application, in some cases mini frameworks, integration software when it has to dovetail into, again, some of those non-Spring best-of-breed solutions to accomplish particular tasks. Again, the core module is the most fundamental part of the Spring framework and the module almost everybody uses. This functionality provides a few things. First of all, it provides the container we talked about, that Spring container that allows us to do things like dependency injection and AOP. The DAO module is a JDBC abstraction layer. This particular module helps us to isolate ourselves from all that very tedious JDBC code. Does anybody really like working with the connection statement and result set objects? If you do, that's fine. JDBC can certainly be used with Spring. But if you want to be lifted up a little bit from that, then the DAO module is something you'll want to look at. This module helps keep a lot of our data access code also vendor independent. In other words, if you ever had to work with SQL with Oracle versus SQL and DB2, you know that yes, we have an ANSI standard SQL, but not all SQL is created absolutely equal. And something like PL SQL may be a little bit different than SQL you'd use with DB2. The data access objects and the data access module help us to kind of isolate ourselves from those differences. Working with the DAO module is also something known as the ORM module. This is a module that helps us integrate Spring applications that want to do persistence with technologies like Hibernate or JPA, Java Persistence API. These modules, if you will, take those best-of-breed solutions and help bring them into the DAO Spring format. The AOP module, as the name would probably imply, gives us the framework within inside the framework, gives us that cross-cutting concern mechanism to do aspect-oriented programming. The Java Enterprise module gives us all sorts of capability to integrate things like Java Messaging Service and JMX and EJBs into our Spring applications, but doing so again in a way that abstracts away a lot of the kind of fine details and minutiae that are part of those Java Enterprise APIs. Lastly, the Spring Web module provides several pieces for us to build MVC-styled web applications. In particular, it also offers us the ability to integrate with very popular packages in the MVC area like Struts, JFS, and Tapestry. Now, every day, Spring is getting bigger and richer. If you go out to the Spring Framework website, you'll find that more projects, more releases of those projects, more modules are coming and going all the time. So the Spring Framework today, sadly, is no longer distributed in a single jar file. It's just gotten too big for that. Many of the sub-frameworks and APIs require us to download and bring in another jar file. For example, the Spring jar file has always been incorporated in spring.jar. That's the core module and a few others. But today things like Spring MVC sit in their own web module and web jar file. Web MVC jar file, I should say. So even though we have a lot of modules and even though Spring is getting big, it still tries to keep to the lightweight label, and it tries to, even in those modules, be as small as possible and non-intrusive. In other words, allowing your code not to be tightly coupled to any of the Spring API. Additionally, you'll find lots of project teams out there. In some cases, third parties have started to glom on to the Spring framework. Everybody recognizes this is a wonderful framework offering lots of capability. Why not integrate to the best of breed in this DI AOP world? So if you go out to the springframework.org site and you take a look at things like some of the Spring projects that are listed out there, you'll find capabilities that go well beyond some that I've mentioned here today. Even things like help in your IDE that work with the Spring framework are provided. And you'll see here just a snapshot of some of those projects. Again, you need to do web services work, try Spring Web Services. Security work, how about Spring Security? You name it, and there's probably something out there in the Spring environment today, some of which are going to be listed off the Spring website's projects file, and others you're going to have to do a little bit more digging across the internet for. But there's probably something in your arena to help integrate your API need into the existing Spring framework. Now, how do we obtain Spring? Well, we go to springsource.org to their download site. There you're going to find a list of releases. Obviously, the most recent release is probably the one you want to take a look at. But in addition to the Spring framework, Spring is actually one of those frameworks, one of those projects that also uses lots of third-party open source jar files as part of the framework. For example, logging. There's a way to use and integrate log4j with Spring framework. So if you'd like, when you go to the download site, look for the dependency downloads. These will include all those third-party jar files and releases that you're going to need as part of your Spring environment. It's a little bit bigger, yep, but with that dependency download, you're going to get not only the Spring libraries, but also all the open source Java libraries you need to actually run your Spring environment. As of Spring 2.5, Java 1.4 environment or greater is required. Once you move up to Spring 3, Java 5 is required. So those are hard and fast rules. Depending on your environment, you'll know which version of Spring you can support. Now, in the Spring download, what are you going to find? Well, in particular, in that download, you should find the spring.jar file. That jar file, again, contains many of the modules we talked about, not all of them, but many of the modules we talked about, including the most important of those, which is the core module, giving us, again, the Spring container and the basics of the Spring API. In Spring 2.5, the Spring jar file is still fairly lightweight, 2.8 megabytes. Again, growing a little bit here over time, but what Spring is trying to do, or I should say the group that operates the Spring project is trying to do, is keep still the basics into a relatively lightweight environment, and then modularizing some of those other pieces, things like Spring MVC that you may or may not need, in separate jar files. Alright, so now that you know what Spring is, why it's used, and where to get it, let's take a look, maybe, at how Spring is used. So we want to run through a little bit of an application here, if you will, kind of a hello world application in the Spring world, just to start to see how Spring works. Again, we'll be talking about more of the details of the Spring API and the Spring framework and things like the container throughout class. But this should start to give you a little bit of a flavor about how the Spring environment is set up and how it uses Spring Beans to develop and build and work with applications. In this particular case, we're going to be building an application that is really just a Java SE application. Remember, Spring Framework was meant to build enterprise applications. But this sample code should give us the indication that the Spring Framework can be really used for all types, shapes, and sizes of application. And in particular, what we're going to build as a simple little electricity calculator, or more appropriately in Spring vernacular, a simple electricity calculator beam, which can be used then in other Java SE applications. So let's take a look at a simple little Spring application. So as we begin to look at our example application, again remember that one of Spring's important philosophies is that coding to interfaces is better. Again, this is a rule we should apply to all Java development, but Spring says this is key, or one of the keys, one of the key philosophies to application development in the Spring framework. Interfaces help promote better flexibility, again allowing the implementation class to change at some point in the future. So as our first step in developing our little simple calculator here, our electricity calculator, we're going to create a simple interface. In this case, the calculator interface. In the calculator interface, we've got three simple methods: ohms, amps, volts, allowing us to, as the calculator would do, convert volts to ohms, ohms to amps, and ohms to volts. Now, as any interface would do for you, it doesn't define the implementation, just defines the contract of what the service is going to offer. So we've got our interface, our calculator interface. That's step one. Next, what do we need? Well, we need an implementation of that calculator interface. In this case, we need what we call a spring bean to implement that calculator interface. And here we go. Calculator implements our calculator interface. And if you're a former electrical engineer or have some familiarity with electrical apparatus and calculations, hopefully these methods will ring true to you. We're going to set up a method here called ohms, which again allows us to convert from volts to ohms. We've got another method, amps, which allows us to convert from ohms to amps. And lastly, a method called volts that allows us to convert from ohms to volts. Notice also that there is an instance variable in this class, in this calculator input class, called watts, and a setter for that variable. And that variable is used in many of the calculations to help provide, if you will, kind of the constant to be used in our calculations to ohms, amps, and volts. Now, how does that watts get set up with a value? We'll come to that in just a second. Okay, so our impl for our calculator has been set up along with our interface. Now, with regard to our spring bean, the important piece of how this bean is going to be used is dictated by configuration. We have to tell the spring container that is going to use this new calculator impl class to help other services be able to do calculations. We have to tell it how we want that particular bean set up, how we want it to be configured. We do that in this particular case through an XML document. Now, you could use other apparatus to configure your spring beans, again most notably using annotations, but we're going to use simple XML here, which is really how Spring started, using entirely XML to configure our spring bean called the calculator impl. So the XML is here, and we'll see that the root element in all spring bean configuration files is called beans. Yep, a lot of namespace references there, but then inside of the beans definition is a bean, in this case for our calculator impl bean. Now, our calculator impl bean we're going to call ohm calculator, and you'll notice that it has a child element called property. Notice the name of that property called watts. What do you suppose that relates to? Yep, that's going to relate back to that watts instance variable in our calculator impl. Okay, so now we've defined this ohm calculator in our spring bean configuration file. And by the way, the name of this XML file could be just anything you'd want. We'll name it spring beans XML. So now we have our calculator impl defined, and we have a spring bean configuration file which defines the, if you will, the makeup and the structure and the configuration of that calculator impl. Now, how do we use our spring bean in this case, a Java SE application? Well, in this case, I've set up a little Java SE application with a simple little main method. So we've got our main method here in a class called oscilloscope. And inside of the main method, the very first thing I'll do is ask for something called the Xml Beam Factory. What is the Xml Beam Factory? Well, in fact, this is our spring container. This is the apparatus that will actually run our spring beans, in this case our calculator impl. And when we build our Xml Beam Factory, you'll notice that we provide it the name of our spring bean configuration file, essentially saying, container, when you come up, go read the spring beans XML in order to understand how our beans are to be configured, so that when we ask for one, we'll get exactly the type of bean we want set up the way we want it. Now, how do we use that container, which we call factory? Well, we simply ask the factory to give us a bean. Factory.getBean. And we provide the name of the bean that we want, in this case Ohm calculator. Now where did that name come from? Well, again, let me back up a slide and refresh your memory to the fact that the ID of the calculator impl that we provide in our Spring Bean configuration is called Ohm calculator. So we're essentially asking for that calculator impl bean. You'll notice we're using interfaces, so we're going to cast that to calculator type so that maybe the implementation might change later on. In fact, we'll talk about that here in just a second. So I've got an instance of my calculator impl. That was created right at this point when we see factory.getBean. It was created by the Spring container. You'll notice I never had to do new calculator impl. It's done for me by the container. Oh, by the way, at that very instance as well, the Spring Bean container is going to read our configuration and determine that, the property of watts should be set to a value of 15. That's dependency injection at work there, folks. That's that IOC that we talked about, giving or providing data and or other objects to our Spring Beans. In this case, a simple integer value to the watts property. So that all happens courtesy of this one line of code. Now, once I've got my calculator impl, how do I use it? I simply call on its methods. In this case, asking to convert to ohms, a value of, I think it was 5 amps, or maybe it was watts, I'm not sure which. We've got converted there. Yeah, actually, I'm sorry. Number of ohms for 5 volts. So we're seeing 5 volts converted to ohms. And that's Spring Beans being used in the Spring container. So that main method in the oscilloscope class is actually creating the Spring container and then calling on the Spring container, which is an instance of this XML Beam Factory, to give us a bean. In particular, give us the bean for our calculator impl. And it dependency injects the value of 5, not 15, sorry folks, that's a typo. Dependency injects the value of 5 into its property, its watts property, and allows us to use that data inside that class. Now you might be wondering why we're actually using the calculator interface here. We could have just asked for an instance of the calculator impl without an interface. However, the interface here helps to highlight the fact that underneath the covers we can actually change code and allow the container to help us in callers of that code very easily adjust. For example, let's say in the oscilloscope world that the oscilloscope required us to make calculations in kilojoules per second versus watts. And if you're not familiar with the electrical industry, 1 kilojoule equals essentially 1,000 watts. Now, if that was the case, how would we change our application? Well, in fact, all we really need to do is go and now implement a kilojoule calculator implementation of our calculator interface, providing the same methods that you notice here: ohms, amps, and volts. But now what we're doing is not using watts as a means for that calculation. Instead, you'll notice that our class now has a kilojoules property, and it uses that kilojoules property in order to be able to do the calculations of ohms, amps, and volts. In our configuration file, our Spring Bean configuration file, instead of having a calculator impl, we'll have a kilojoule calculator impl. In fact, we'll call it the same thing. We'll call it the ohm calculator. Now we provide a dependency injected value of 0.015 for kilojoules as opposed to what we set up for watts. And now how does the actual oscilloscope class that uses our container and our beans change? And the answer is it doesn't change a bit. By using interfaces and having the users of our Spring container and our Spring Beans apply those interfaces in their code, we have completely loose coupled application code. Oscilloscope classes that use all of our service classes, things like our calculators, now don't have to know about the details. The implementation can change readily. And the Spring framework helps us with that. It says, just give me the name, an ID for your particular calculator, how it's implemented, I'll handle those details. I won't let the users of that, in this case the oscilloscope class, be concerned with all those details about how to put together a calculator or even what it's implemented as underneath the covers. So complete loose coupling between callers of, the oscilloscope in this case, and implementers of, calculator impl in this case. And that concludes our chapter as an introduction to the Spring framework. in this chapter, again, we've learned a little bit about the fact that the Spring is an open source application framework that helps to reduce the complexity of our Java applications. Again, meant to be lightweight. That lightweight term comes in a couple of flavors. Lightweight in terms of its actual physical size, but also lightweight in that it tries to be non-intrusive into our existing application code. It's meant to be a replacement for, or if you will, a more abstract version of a lot of the Java Enterprise APIs. Still uses those under covers, but helps make things a little bit less complex for us in application development. Spring Framework also provides and promotes lots of philosophies that boil down to help making our applications easier and less complex to develop, easier to test and therefore better quality, and more flexible and therefore easier to maintain. And applications built on top of the Spring Framework are usually comprised of just simple plain old Java objects which we call Spring Beans. We configure those via XML or annotations, but the container reads the XML configuration and develops and manages all those beans for us. You can download Spring from springsource.org, and that concludes our chapter. Thank you very much for joining us, and I hope to see you in our Spring Framework class.